afternoon. It should be Wednesday, I think, that you'll be watching this. This is 3-5 video, and 3-5 is a great section because it flashes back to Algebra 1, which I love. So get your notes ready. In your note packet that we've been working on that looks like this, 3-3, 3-4, at the end of 3-4 you've got a blank page. So that would be a great page to do your notes. And this section is all reviewing writing equations of lines. And if you remember from Algebra 1, lines are called linear. We've got a number of different aspects of a linear equation that we're just going to review. First thing is the definition and formula of slope. Remember that slope is often referred to as rise over run. It's just the way that we measure the steepness or the slant of a line. And the equation for finding slope, remember we use the variable m to represent slope. The change in y is just the difference of the two y values over the difference of the two x values. And as you get into upper level math, I know I showed this last year, this delta symbol is often used as to represent change. So change in y over change in x is a way that we represent that. Slope is obviously a critical feature of a line when we're writing an equation. I want to review a couple of forms of linear equations. Remember that we've got what's referred to as slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. And just as a quick review, remember in standard form, when we had something like this, 5x minus 3y equals 15, one of the benefits of standard form is that it was really easy to find the intercepts by doing what I referred to as the cover-up method. So you cover up, or you make the x value 0, and then you figure out what y value will make this true. So negative 3 times negative 5 is 15. Then you cover up the y, or you make the y value 0, and you figure out what value of x will make that true. And then you've got your two intercepts, and you can quickly graph them. Now in geometry, the definition of a line is that there's one unique line that passes through 2 points. So you need 2 points to define the line, and that's why we often graph the intercepts and the line between it, and we're ready to roll. Just another quick review for your note sheet. Remember, we learned this in Algebra 1, but as we've begun in geometry to talk more about parallel and perpendicular lines, you've got a little bit different picture of those. But in Algebra 1, we referred to parallel lines as any two lines that have the same slope but different intercepts. So parallel lines, for your notes, have to have the same slope. Why do they have to have different intercepts? Because if they didn't have different intercepts, they'd be exactly the same line and therefore not parallel. They'd be intersecting at infinitely many points. And perpendicular lines have slopes that are opposite reciprocals. So for example, y equals 1/2 x plus 3. The opposite reciprocal of 1/2 would be negative 2x minus 4. And I just made these up so that I knew that they could have the same y-intercept. But what we're really focusing on are the slopes. Okay, with that, we're going to do a couple practice problems. If you run out of room on that page, you can go into note sheets. Hopefully it's not too hard to read, but I'll try to zoom in here. The first thing that you'll have to do is write an equation of a line in slope-intercept form if the line is given to you on a graph. Okay, so this is probably the easiest. This is the point 0, 4. So as you can see, this hits the y-intercept at 4. So that means our b value is 4. And then to calculate the slope, you can start here and just calculate how much do you rise, how much do you run to get back on the line. Or you can pick 2 points on the line and do the slope formula. Well, in this case, if you notice that if you drop down 2 and go over 1, you're going to be right back on the line. So therefore, your slope is going to be negative 2. So as you can see, when we put that all together, a y-intercept of 4, a slope of negative 2 gives us that equation. So that one's pretty easy. Okay, then we get into example 2. It's a little trickier. It says, write an equation of the line that passes through this point and is parallel to a line with this equation. Okay. So looking at the problem, we want to think about our givens. We're given that it has to pass through this point, and we're given that it's parallel to that equation, so that means our slope has to be the same as this, so our slope has to be 2. Okay. So then from there, we go ahead and do some arithmetic or some algebra. So we're going to start with this basic equation, y equals mx plus b, but we know m is 2, so we're starting with this formula. And I'm going to do a capital B just so we don't mistake it as a 6. And then hopefully you remember from Algebra 1, to find b, we use our given point, and we plug in our x value, we plug in our y value, let me calculate. So 1 equals negative 2 plus b. So in this case, b is going to equal 3. And then we put that all together, and if you notice over here, when you put it all together, the equation comes out to be y equals 2x plus 3. We got the 2 from being parallel, and we got the 3 from substituting the x and y value in. Okay, so can you guys try now to do the same thing here? Write an equation of a line passing through the point 2, 3, but this time it's perpendicular to this line. So if it's perpendicular, the slope has to be opposite reciprocal. So that means the slope has to be 1/2. So put a star by this, and in your notes, do the work, and I'm going to check that in your when you come in on Thursday. Okay, the last example I want to show you or have us work through is, what do you do if you need to write an equation of a line that passes through 2 points, and that's all you're given. You're not given that it has to be parallel to anything or perpendicular to anything. This is all you're given. Well, if you think about linear, one of the key things you need to know is slope. So step number 1 is you're going to find the slope. So we're going to do change in y. So we're going to subtract the 2 y values over change in x. Subtract the 2 x values. So you end up getting 3 over negative 3. So our slope is negative 1. So step number 2, we take what we know. We know the slope is negative 1, so we're going to start to build this equation. Y equals mx plus b. The m is negative 1, so we plug that in there. And now you pick either of these points. Both of these points will pass through this line, so pick whichever one you want to do just what we did in the previous example. Substitute for x and y. So when y is 2 and when x is 1, substitute that in and figure out what b is. So in this case, b has to be 3. So you plug it all together. Your equation is negative x plus 3. Okay. Pretty easy there. The last thing that I just want to point out to you is we did have some work with this in Algebra 1. Oh, I'm sorry. We're good on that. We don't have to do that. All right. And so example 4 looks like this. You'll be taking a graph The graph models the total cost of joining a gym, write an equation of the line, and explain the meaning of slope and y-intercept. Well, if you take a look at this, they give you 2 points that are labeled. If they don't give you those, you find those points by using your information on reading graphs. So they give you the 2 points, and the first thing you're going to do is find the slope. So it's hard to read what those 2 points are, but the cost for 2 months was $231. The cost for 5 months was $363. So we do change in y over change in x to get 44. Now let's take a look at what that means. On the y-axis, this is cost in dollars. So these are all dollars. So when you talk about meaning of slope, sometimes it's beneficial to go back and put the labels in. This is dollars, and the denominator, 5 minus 2, these are months. So when you put the label on there, when this is reduced, this is not just 44, it's $44 per month. Since it's positive, it means it's going up. So our meaning of slope here is that our gym membership goes up $44 every month. So it's real easy to define slope when you just go back to the problem and you put your labels. And you get those labels by just reading the graph. While we're here, what would be the meaning of the y-intercept? So it looks like the y-intercept to me looks like it's about, well, I guess we can guess here, but let's go through the rest of our steps next. So then remember from previously, we're then going to substitute 44 into this equation. And then we're going to pick one of our ordered pairs. So in this case, they put at 2 months, it was $231. They substituted those in, found out that our y-intercept was 143. So our equation looks like this. But now we have to go back and define, what does the y-intercept of 143 mean? Well, it hits right here at 143 when months is 0. So that's your original startup cost. That's to even become a member, you have to pay a flat fee of $143 before you even begin using the gym. Alright. Another thing that I'll check, please do this problem real quick. Can you please find the y-intercepts, the x and y-intercept, and make a sketch of that? And I'll check that at the beginning of the class. So pause the video if you're still not done. And the last thing that I'd like you to do and that I'll check is this problem. The equation y equals 50x plus 125 models the total cost of joining a climbing gym. Can you please write down what is the meaning of slope and y-intercept? You don't have to graph it, but I will check that as well. Okay, that's your video for today, and make sure you get the starred things done.